Good afternoon, good morning, wherever you may be. Welcome back to the Fastly YouTube channel for our monthly developer livestream. My name is Kalen Blanks, and I am part of the developer experience team here at Fastly. Over the past 30 days, we've been really busy here at Fastly. If you're an existing customer or you follow us on social media, you'll have heard about or even attended our annual customer conference, Altitude, that took place in New York City at the end of September. There were so many fascinating talks, not only from Fastlians across the organization, but also our dedicated customers that are really pushing the boundaries of what you can do at the edge. Our VP of Developer Experience, Anil Dash, took to the stage during the keynote to talk about how we are working to provide the best environment for anyone to start building at the edge for the first time. As well as the keynote sessions, Andrew Betts, who joined our stream a few months ago, led a session along with the team at Paramount to help showcase some powerful use cases for compute. And you may notice that I just said compute. I didn't say computer edge. And that's because going forward, our serverless platform is simply known as compute. We want it to be clear to everyone that all of our offerings are at the edge, and compute is a seamless part of the family. So from now on, it is just going to be compute. I may slip up a few times, but we've been working on this for years, so it's really exciting to make that announcement. So one session that really stood out to me at Altitude was from Lynn Clark, who is not only the artist behind the fantastic Code Cartoons blog series, but also our very own Director of Compute Engineering here at Fastly. She talked about how Fastly is working to build the future of WebAssembly at the edge, and specifically our vision of securely sandboxed WebAssembly components that allow you to build fast, feature-rich services without compromising on security. Let's take a look. So that's our vision for the future of WebAssembly, which is super exciting, but someone does have to do the work to make it a great experience in the languages that we as developers want to use most. And that's why today I'm very excited to welcome to the show Jake Champion, former star customer, open source contributor, and now one of the amazing principal engineers who has been maintaining and expanding our somewhat unique JavaScript runtime. Welcome to the show, Jake.
Thank you very much. It's a pleasure to be here.
So over the next 30 minutes, Jake is going to let us in on some of the magic that makes JavaScript on Fastly so powerful, as well as our plans for the future of JavaScript in a component-based world. We'll talk a bit about how JavaScript works on compute, and there will be a chance throughout to answer any questions you may have. So make sure to say hello to us in the chat. So Jake, first of all, what did you think of Altitude?
I haven't caught up with all of the talks yet, but I did see the highlights playlist that you put together on the YouTube channel, so thank you for that.
No problem. Did you hear about the interactive display we had at the Developer Hub booth?
I heard about it, yeah. It's the Top of the Pops one, which I've played before, but I wasn't there to play it this time.
Oh, that's a shame. Well, for anyone who wasn't lucky enough to make it also, we had booths at Altitude showing off the best parts of Fastly. My personal favorite was the one that was representing our award-winning Developer Hub, but we really wanted to provide a memorable experience for everyone this year. So we showed off our interactive Top of the Pops game, where you can test your intuition with live metrics from our points of presence. It was a really great way to get people engaged. Perhaps we can find a link to that and share it with our viewers next time. Okay, that's enough about altitude. Let's get into the exciting developments in JavaScript. So, Jake, you build the JavaScript runtime that is used by thousands of developers to build on Fastly Compute. What exactly does that entail?
So lots of serverless platforms out there are built upon JavaScript runtimes such as V8, meaning that they're really great at running JavaScript. When it comes to more demanding workloads where you may want to use a different language, which you then would use like via WebAssembly. WebAssembly in those environments is usually often seen as like a second-class citizen, whereas on Fastly Compute, our platform is WebAssembly first. Our WebAssembly engine of choice, which is one that we build called Wasm, has no idea what your language was like originally written in. It could be written in any language. It's up to you as a developer to package your application, compile it down to WebAssembly. So you could use like Rust, Zig, Go, whichever language you want, as long as it compiles to WebAssembly. And it would run on our platform. And we actually provide SDKs to give you a bit more of like an idiomatic way of working on our platform. And we provide those in Rust, Go, TinyGo, JavaScript. And as I said before, you could use any language that compiles to WebAssembly. So we've even got developers in our community that have made their own SDKs in different languages such as Swift, which is pretty cool to see.
That is really exciting. Before we go any further, I just want to apologize to the viewers. Apparently, the video from Lynn's talk did not have any audio. What I'm going to do is post a link to her full talk in the chat. So if anyone wants to follow up on that, it's definitely worth a watch. Back to the topic at hand. I want to know, JavaScript I thought was an interpreted language. I thought WebAssembly was just for C or Rust. How are we making that work?
Good question. Yeah, JavaScript is an interpreted scripting language, so it's not as straightforward as the compiled languages that you mentioned, C, Rust, or Go, where the compiler can target WebAssembly like it could any other platform. For JavaScript, what we actually need to do is we need to build a JavaScript runtime that can compile to WebAssembly and then actually use that runtime to run your JavaScript code on the fly on our platform.
That sounds pretty difficult. I mean, as a developer, how would I ship my JavaScript code with a runtime like that to work on compute?
We certainly wouldn't expect you to, as a JavaScript developer, to build your own JavaScript runtime that compiles to WebAssembly. For this reason, we've built our own JavaScript runtime, which is based upon Mozilla's SpiderMonkey JavaScript engine. And we ship our runtime as an NPM module, which you can then use to build your JavaScript applications with. In fact, it's quite easy to get started on Fastly Compute with JavaScript thanks to our CLI and our starter kits. You may not even you should be able to just like deploy your application without realizing that it's running in this like less than typical environment where it's WebAssembly instead of like native JavaScript or something.
So what exactly does the npm module do, and why are we shipping it with npm?
Yeah. As I mentioned before, we are using SpiderMonkey as our underlying JavaScript engine, which I think is the oldest open source C++ project. Someone can fact check me on that and see if I'm wrong, but I think it is. My teammates did the really complicated work of uh, porting SpiderMonkey so it's able to actually compile down to WebAssembly, which was a humongous amount of work. And so we packaged all of that into an npm package, and we shipped that in alongside that JavaScript runtime that we ship is actually also a command line tool. So you as a JavaScript developer, all you need to do is run this command line tool, give it your entry point JavaScript file to your program, and then it will combine that with our JavaScript runtime and turn that into one single WebAssembly file, which you can then upload onto Fastly Compute and have it running.
That's pretty exciting. And how would I know about this as a developer? How would I know how to add this to my project?
Oh, so we have uh, quite a lot of like tutorials on the Dev Hub. We also have a wide range of different compute starter kits that are also embedded in the CLI. So you could do like Fastly Compute in it. You had this interactive prompt where you can decide if you wanted to start your project using JavaScript or TypeScript, or if you wanted a really bare bones JavaScript packet project to start with. So that makes it like incredibly quick for you to initialize a project and get started immediately writing your own application code rather than having to remember how to set it up for Fastly.
That's great. I also have my own shameless plug to make. I have to mention Fastly Fiddle. Fastly Fiddle is our browser-based tool developed by my own team, and it means that you don't even need to have Node.js installed on your machine before you can build with JavaScript on Computer Edge. It makes the whole experience a lot more accessible to those who may not have worked at the edge or with WebAssembly previously. It's a really useful tool.
Yeah, I actually use it several times today. I was using it just before this as well to help debug, answer a customer question, write a little fiddle, see if my assumptions were correct, and then send it to them so that they could see the exact same fiddle running.
And if I'm not
Great.
wrong, that was literally 2 minutes before we went live. So
Yeah.
that really shows how quick and easy it is to just like whip up a proof of concept.
Yeah.
So I definitely recommend Fiddle. We will mention that at the end and make sure you know where to find that. So I have another question. I wanted to know how our JavaScript SDK is different from your typical JavaScript runtime.
Hmm. As I mentioned earlier, ours is running within WebAssembly, which brings a host of benefits such as um, secure isolation and sandboxing. And those are benefits not just for Fastly's platform itself, but also for the developers' applications as well. All communication with the outside world happens through our strictly defined Fastly Compute System Interface, which means we're sure that any rogue dependencies that you may have accidentally included in your application can't access outside systems, which in a world where package ecosystems such as npm struggle with malicious packages and like library takeovers, it's a huge advantage to our platform. In the future that Lynn talked about earlier, which you're going to post a link to with working audio, she's spoke about how it will also allow JavaScript developers to easily pull in dependencies that could be written in any language, such as Go or Rust, and you wouldn't even realize that they're written in those other languages. It would just be completely transparent to you, which is pretty cool. You can have your really performant intensive app functions written in like Rust and still have the nice JavaScript scripting language for your main application.
That sounds really exciting. I'm wondering though how you would kind of define these interfaces between the languages and between the capabilities that the platform offers. Could you go into a bit more detail about that?
Yeah, the what I call the Fastly Compute System Interfaces. Yeah, so Fastly Compute takes advantage of more than just like the standard like WebAssembly that we've had for like the past 6 or so years. We are actually founding members of the Bytecode Alliance, which is a group that is working on standards to improve WebAssembly across all platforms and propose new standards to help evolve WebAssembly and make it applicable in more domains. One of these standards being worked on is known as the WebAssembly System Interface, or WASI for short. It allows WebAssembly code to talk to its host application in a fast and safe manner. So this standard allows us, Fastly, as a platform provider, to provide access to our platform's features via a strictly defined set of function calls. And then our SDKs internally use those function calls and expose them to you as a customer in like language idiomatic ways.
That's really cool. What does that look like? How is that actually defined?
So we actually provide an open source implementation of our runtime, which is on GitHub. And it allows developers to actually build and debug their Fastly compute services locally, even offline if they wanted to. Um, So you could actually browse to this open source GitHub repository, Fastly/Viceroy, and you can check out the WitX files that define these system interfaces. You may not have heard of WitX before. It was the first iteration of the format for defining WebAssembly system interfaces. I say it was the first iteration, as Lynn's talk was about the component-based feature, which requires more features than are present in WitX. For this reason, as part of the WebAssembly component model proposal and the WASI proposal, there is a new language for defining these system interfaces, which is named WIT. So WIT without the X.
Very creative, very creative. So I've just posted a link to those the WitX definitions that we currently have in the Viceroy repo in the chat. It looks a little bit daunting, to be completely honest with you. However, I'm curious how all of this text in this file is turning into me being able to respond to requests and send HTTP requests within JavaScript on compute.
Yeah, it's a bit low level what you are seeing in those WitX files and those WIT files that we'll be using in the future. But so for responding and sending HTTP requests in JavaScript, that's a good question. So we're at Fastly, we're very focused on like making sure that we follow standards where they're set, and also contributing back to the ecosystem by proposing new standards or additions to new standards. And so the way that we handle incoming requests and responding to them in JavaScript, in our JavaScript SDK, is consistent with what's known as the Service Workers API, which has existed in browsers for years and is a well-known standard. So we have got the high-level functions of fetch to make a backend request, a request and response classes. So it's very similar. If you've used Service Worker API before, or you've used fetch before, our SDK is going to be very similar to that, which is quite useful. It's not only us that are actually using these standards. In order to prevent further fragmenting the JavaScript ecosystem, ourselves, along with other industry leaders, are members of what's known as I'm going to have to breathe in for this, it's quite long, the Web Interoperable Runtimes Community Group, the Winter CG, as it's known. So that's a group that's planning to document and ensure that all these new JavaScript runtimes using the web platform APIs in a way that's interoperable with each other. So you could write JavaScript for one of these runtimes, and that should work when you start using maybe a different JavaScript runtime. So it's to try and make it less of a burden for JavaScript engineers so that they can ship their code and have it work on all these different platforms, which is much better.
That definitely sounds like the right way to go about it. It sounds a bit like it's in progress, though. I'm wondering, like, at this point in time, are you telling me that an npm module needs to explicitly support Fastly Compute for it to work?
Not really. That's not strictly true. There's a huge amount of modules on npm that you use day in and day out that already work on Fastly Compute with our JavaScript SDK, so long as they don't depend on Node.js like specific APIs, such as trying to read or write to the file system, because we have no file system on compute. So, for example, the two most popular packages on npm right now, Lodash and React, both work on our SDK without you having to do any changes to those.
Fantastic. And how do you see that changing in the future with the component model being introduced onto compute?
So in the future, we hope with the WebAssembly component model that we should be able to allow any module to run on compute regardless of its like internal requirements. because one of the benefits of the component model is that you can virtualize parts of a component, like parts of the imports of what a component's trying to import. So you could like virtualize a file system. So then you could then use a file system API and it would work. I could talk a lot more about this, but we'll probably run out of time. So what I highly recommend, it's one of my favorite talks actually, is going to watch Guy Bedford's most recent talk at WasmCon, where they do this live coding, like 45 minutes of live coding, showing how you can create components, WebAssembly components in different languages, and then have them all working interoperably in a web browser context. I was flabbergasted seeing him just do it non-stop live coding and live demoing for 45 minutes.
Yeah, I was lucky enough to see a similar presentation in person, and to see that everything has actually progressed this far was incredible. We've got a really bright future ahead for sure. I mean, this developer experience is just getting better and better. I'm so excited about it, but we are called Fastly, so I have to ask you, what is the performance like?
So there's a few different parts to this. So we've put quite a lot of effort into building a WebAssembly runtime, the Wasm time project that I mentioned earlier, and making sure that is extremely performant. But that's only useful if your code that's running within that is also itself performant and efficient. So for JavaScript applications, they actually usually require a bit of initialization before you actually get to running your application code. So, for example, when you start running a JavaScript application, it first has to spin up what's known as the JavaScript virtual machine. It then has to create all of the globals and the intrinsic classes. It then passes your JavaScript's source code, turns that into a syntax tree, and then begins executing and optimizing it. And if we were doing all of that for every single time you had a request come to your compute application, it will be just like a bit slower than it should be, because that work is going to be the exact same for every single request that's coming in, booting up a VM, creating the globals, passing your JavaScript source code. So other people on my team realized this and came up and invented this excellent tool called Wiser. A colleague of mine, Nick Fitzgerald, has actually given a really good talk on Wiser itself. What Wiser does is it runs the top level instructions of a WebAssembly file and creates a brand new WebAssembly file with the executed state from running that top level. What this means, if you applied that to a JavaScript program in WebAssembly, is it's effectively running your top level scope of your JavaScript application, and then saving that and creating a new WebAssembly file with that saved state. So that new WebAssembly file already has the virtual machine booted up, all the globals are made, all the intrinsics are made, your JavaScript's already been passed, its top level has been executed. So when we come and run it, it would immediately be running your application's like fetched event handler. And it also means that you could, if you wanted to build like a computationally expensive data structure, if you could do that in the top level, that would actually happen during this wisening time. So during this compilation, before you even deployed it to Fastly. So you can do quite a lot of work there if you are able to do it ahead of time. And if you've been around like JavaScript for quite a while, you may realize this sounds similar to a Facebook research project called Prepack.js, because Facebook also noticed this was like a common issue for websites, where you download a website, you get to the script tag, you download that, you have to pass it all and do this all the same situation. And so they were trying to solve it specifically for JavaScript. I don't think that ever left the like research phase. But as I mentioned before, my colleagues have got it to work for WebAssembly as a whole. So you can run this on any WebAssembly program and it will do this optimization, which I think is pretty cool.
That's absolutely incredible. I mean, I don't think we've been able to do anything like that in the past. Obviously, you mentioned pre-pack, but this does work with any WebAssembly language, which is just incredible.
Yeah, we do this
So,
for all of our JavaScript programs by default. So it's not something extra you need to do. It's applied already ahead of time for you.
yeah, and it's worth reiterating that this isn't something you have to configure. You pull down one of our starter kits, you use the npm package that we distribute automatically with that, and this all happens in the background. It's really, really easy. So the last question I have for you, Jake, is as a developer, how can I start building with this?
So as you mentioned earlier, you could use Fiddle at fiddle.fastly.dev, I think. So you could start playing around with it just in your browser, seeing what's possible. And then if you wanted to take it a bit further, or you wanted to actually deploy it to one of your own websites, you could sign up at fastly.com/sign up for a Fastly developer account, which is for free. And I think you get $50 of credit each month to use, which is more than enough for you to uh, deploy your own sites to it and see what the platform is able to do. If you do actually do either of those things, do tag me so that I can have a look and see what you're doing.
Absolutely. We love to see what you're doing with compute. I would also recommend that you head over to fastly.dev and follow the navigation to head to our community forum because we're trying to grow a community. We really want to see what you are up to on compute. We also are there to help you. So if you have any questions, if you're implementing your own SDK for your favorite programming language, we want to know about it and we want to be there to help you and also share the amazing work that you do. So definitely do those things. Jake, thank you so much for your time today. I really appreciate it. I hope that our viewers have had the chance to learn a bit about how JavaScript ticks on Computer Edge. And I also really look forward to next year, in the future when we can finally be at this point where this beautiful world of components that we've talked about has started to flourish. We have a registry full of components. We have SDKs for every language where it all interoperates. It's really, really exciting that this is what we have to look forward to. Again, Jake, thank you very much. Is there anything you'd like to say to our viewers?
Um, I'd like to come back when we actually do support the full component model and we can do some demos showing what is possible. That would be pretty good.
Absolutely. We will certainly be doing that. I'm going to start planning it right now. Okay. Thank you everyone for watching. We will see you in 2 weeks' time where I will be with my colleague Katsuyuki Omuro and we're going to be talking about Fastly's new real-time capabilities, which have recently become generally available. Make sure to join us for that. Subscribe to the channel if you haven't already, and we will see you on the edge. Take care.